Hello, my name is Tine. In this video I'll show you my new and actually my first CNC engraver I got from gearbest. It's Ortur Aufero 3018 CNC engraver. As always, start with unboxing. This is definitely one of the heaviest boxes I got from China. It weighed about 12 kg. I want a CNC machine for a while, but so far they were a bit costly for a job they can do. But the price of that tiny CNCs dropped quickly, and now we can get a CNC like that Ortur Aufero, which got no plastic parts, for about $250. I think that's a great price. Even if it can cut harder material, it'd be great to learn something about CNCs. As you can see, it's a DIY CNC, so you need to assemble them. In the box are a lot of parts, and everything is really nicely protected with foam, so even if the package is heavy, there's little chance to damage some part during transport. I have always loved Lego, so that's really nice view. Let's check a bit closer what we got in the packet. We got here a lot of aluminium. First one is wire extruded aluminium profile for base plate. Then we got 8 black anodized extruded profiles for frame, 2 L profile which come under the bed, 4 pieces of 12mm linear shaft, 2 pieces lead screw, 2 massive pieces of aluminium for front and rear with built-in bearing, 2 steel plate for frame, mounting accessory, coupling, nuts, tools, USB key, 2 pieces of 1/8 end mill, 1/8 ER11 collet, linear bearings, lots of screw, stepper motors, AC cable, 24 volt 5 amp power supply, motherboard into steel housing, touch screen for offline control into 3D printed housing, and complete pre-assembled massive Z-axis with spindle motor. And now the best part, assembly. Beside of free software, firmware and drivers, there are also clear video about assembly on USB key. Assembly is simply, and if you ask me, way too fast, cause I really enjoy that part. Everything go together like it should, without one single problem. Really well done, Ortur. Okay, frame is assembled, but before I plug the electronic, let's check them a bit closer. Here we got a compact motherboard. It's really small for all the things it offers. We can see it's full of plugs. Here we got an STM32 microcontroller, power jack, USB plug and offline controller plug. Cables for switch and motor are directly soldered into PCB. Then we got here 4 stepper drivers and plugs, 4 plugs for limit switches, probe plug for setting Z-axis 0 and many other plugs. I think someone with firmware knowledge can pull much more out of that board. On other side of board are transistors for motor PWM control. Everything is closed into steel housing which work also as heatsink. Into 3D printed housing we got offline controller. On one side is color touchscreen and on another we can find micro SD card, micro USB port, Wi-Fi model and so on. The machine is now assembled and ready to use. What can I say? The frame itself is really solid. There are a lot of reinforcement with the screws on right places. Every piece is solid, so entire machine is quite heavy. And man, this spindle motor is big. But during assembly I noticed 2 tiny weaknesses, which can be easily improved. First one is airness on linear nuts, on all 3 axes. Nuts are made out of 2 pieces, and between is the spring, so it pushes them apart and eliminate the airness. But the spring is funny soft, so when we make any force on the axis we can feel the airness. On X and Y axis we got about 0.1 mm, and on Z axis is almost 0.2 mm. But I'll make here an easy modification. Just make a treat into 1/2 of nut, so I can push the nut apart with setting the screw, as that got solved the bigger machines. Second tiny issue is coupling. On the motor axis fit fine, but the lead screw is a bit under-dimensioned, so we need to tight screw to the limits to get optimal grip. But I got a mini lathe, so it won't be a problem for me to fix that. I just turn the end of lead screw to smaller dimension to get flat surface without treat and make new smaller coupling. Okay, let's power it up now. I got many things to learn during making this video, so I don't make attention on offline controller. but we got many functions there. But the basic I know is moving the axis, control the spindle motor, set the 0 axis and so on. We can also get the Wi-Fi settings here and a micro SD card reader. I didn't try to control offline yet, but I think if we put a G-code on SD card, we can set the 0 axis and run the machine offline. When I tried to mount a piece of wood on the table, I noticed that the holders are without thread, so I cut the thread for easier clamping. But on the end anyway I used my old homemade clamps from some mini mill I got, cause they're easier to use with different height of workpiece and leave no traces on the base plate. When I insert the collet and mill, I noticed that there are no screw-on coupling. It's heated up and pushed on the motor axis, so I can't remove them, but it's running nice in center and hold the two axis rock solid. Spindle rotated about 9200 RPM. I tried to plug on regulated power supply to about 35 volts. Seemed like motor can handle that voltage, but I only got 3000 more RPM. And now the software. They're all we need on USB-K we got with machine. As I say, it's all new for me, so I'll just quickly show how to use it for total beginners like me. Firstly, install the drivers. Candle software is for reading G-code and communicate with the CNC. We just copy entire folder to a PC and run. We don't need to install them. For making G-code we got here freecad. It's in quite powerful software with a lot of function. But they're a really good freecad wiki site with a lot of information, and also there are a lot of video on YouTube about freecad. So I just quickly show how to make G-code to cut out a cube with a hole. Click on create new or file new. Then select part design workbench, then create body and create sketch. I select XY plane, where I make a sketch of square and define dimensions. Then close the sketch and click path to extrude square into cube. In my case it's 20 by 20 and 10 mm height. Then select top surface and click create sketch again, so we draw the circle on top surface. Define the dimension and close the sketch. Now click pocket to cut hole out, in my case 5 mm deep. And I got finished model I want to cut. Of course we can also import files like STL and many other files and create G-code out of them. Now I need to make path and create G-code for CNC cutting. To do that we need to go on path workbench. Click on create job and select model you want if you got more bodies. Then under setup define stock. Basically I set all this to 0, but in that case I define size of my chipboard. My model is 10 mm high and the chipboard is 13 mm thick, so I add 3 mm in Z-axis. Then go to Tool tab and define our tool. Click Add and select Tool. I already got a defined tool which come with the machine. Otherwise, click New Tool, define diameter, length and so on. Now select one or more tools and click Create Tool Controller. Now I got here defined tool, so default can be deleted. Here we also define the speed of cutting. First window is for horizontal feet and second is for vertical feet. We can set them also if we click Edit. So far we define stock and tool. Now we need to create operation. Because my stock is thicker than the part I want, I firstly make facing operation. So click facing and define pattern of cutting, offset and other. I set step over % on 50. That means that only half of tool diameter will cut on every pass. Then click heights. It's automatically calculated based on stock. We'll see later. And then go to deep step. Start deep is already defined based on stock, which is 13 mm thick, and it's okay. Final deep is 10 mm like piece, and it's okay, so I just changed the step down settings to 1 mm by pass. Click OK and we got created facing path. I want to face a bit bigger area, so click on face mill and edit. And set material allowance to 3 mm, so it mill a bit bigger area around the part. Here we can see that the safe and clearance height is calculated based on stock. If you don't define the stock, this number is very important. Basically I don't define the stock, so set both 1 mm more than workpiece thickness I want to cut. Okay, next I want to cut a hole, so click on hole bottom surface and then click pocket operation. Again define pattern of cutting, deeps and so on. Starting height I set to 10 mm, because it's already faced milled to 10 mm height, and it doesn't need to cut from 13 mm as the stock height is, and save some time. And then make last operation to cut the part out. Select one side surface and click on contour path. Then again define the directions of cutting, height, step down and so on. Click OK and voila, we got defined everything to prepare G-code. But I noticed some Z-axis travel lines are too high here, so edit the contour operations and set safe and clearance height to 1 mm more than stock to save some time. Now click the simulator button and click play to check if everything is set as we want. I tried to show you a few basics here, either you get it soon after start playing with all the settings, it's not that hard as it look. When exporting G-code we need to select job, otherwise the G-code will be empty, or it include only operations we got selected. So select job that include every operations and tools. Then go to file, export, name them and save. Then select GRBL processor. Here we can also see the G-code. Then plug the USB cable, which didn't come with the machine, to CNC and PC. Turn on the CNC power switch and run the Candle software. Click connect and we're online. Now import the G-code we made before and set the 0 points. We can move each axis manually with a knob and 3D rods, or use jog here in the Candle software. Here we can set steps and speeds. That's right moment to show you how loud the machine are. Steppers make lot of noise during slow movement, but not when running faster. But don't worry, you won't hear them while spindle working. The scratching noise is here because I didn't lubricate or grease anything. I do that right after first upgrade. I'm sure that just a tiny layer of grease will shut down that horrible noise. Most important is to set Z0. Move down Z-axis that much that it touch the bottom plate I use so it won't cut the table. When the position is OK, set Z0 and then with the jog move the Z-axis up. Don't do that manually, so it know where the 0 is. Then set the X and Y0. We can see here in G-code that the 0 position is in front left corner, but it depends where we draw or move the piece into freecad. So I set mill to left front corner on workpiece and set X, Y, 0. The G-code won't start the spindle to me, I need to set something else, so I start here manually and then send the G-code to start milling. During milling we can override speed and spindle RPM out of Candle software. And I got my first CNC cutted piece. Measures are surprisingly accurate, it's about 500 mm bigger. And the edge of cut is nicely for the chipboard. Now I import STL file of my logo into freecad, convert them a few times to get solid piece and make G-code for cutting. As I said, there are a lot of video on YouTube about freecad. This time is spruce wood, which is soft and a lot of fibers, so result isn't that good. Next I try to make engrave of my logo into cherry wood, with old unsharp 1.5 mm end mill. I definitely need to buy some collets and mills. Result is much better, but some tiny letters didn't hold the force of unsharp mill. 0 wasn't set it perfectly, so it didn't come true. On top surface are stay some hair between the lines, because I use 100% step over. So if the tiny mill bent just a bit, that's happened, but it can be easily determined with setting step over to about 80% or less. But I was surprised how nice is edge of cutting. I cut with 1 mm steps. Lines are a bit visible, but cutted area is silky smooth. Then I try to cut plexiglass, but it's harder than I was think. Maybe just because of my mill, because it start melt the plexi and stick to a mill. So I must lower down the moving speed and spin the speed down to 2000 RPM. What about carbon laminated plate? It cut like butter and the edge is nice. Only where I change the Z position are visible some traces. It'd be definitely useful also for making PCBs, but I don't got engraving mill, so I improvise and just grind the end of a drill. On gearbest site I read the note that it's strictly forbidden to cut the harder material like aluminium or steel. But I couldn't resist, so I make a try on my own risk. Firstly I try to cut 3mm soft aluminium with speed 5mm per second and 0.2mm cut per pass. There was lot of noise and tiny vibrations, especially when changed the Z-axis position, but with adding alcohol for cooling and lubricating it worked. Edges isn't so smooth due to vibrations, but still not that bad. What about 5mm thick strong T7 7075 aluminium? That tiny CNC can cut also that hard aluminium. Slow, but it can. Edge of cutting isn't perfect, but we can see on that piece that also professional CNC doesn't make the perfect edge. I think it'd be just okay to make some RC parts. I need to tell you one more thing. The CNC I received is from development time. Info on controller says it's from February 2020, but they start selling somewhere into end of October 2020. We can see here on gearbest site that it's already got some improvements. First difference I notice is much more solid IGS complete aluminium spindle holder. Mine is attached on 5mm L profile. We can notice also limit switches on all three axes. Then there's a stop switch and controller holder. Look like the X motor is on other side. Also the side of frame is from solid piece of aluminium. Mine was assembly from extruded profiles and steel plate. And here under the bed we can see more solid linear bearing holders. If all that's true, you'll got much better CNC machine like I tested in that video. So I'm sure that with modification airness on nuts and using some better spindle with bearings, that machine can easily handle cutting aluminium. I don't know other 3018 CNCs, but from the photos I can say that the Ortur is much more solid and heavy like other CNCs, which contain lot of plastic, even 3D printed parts, and everything look more weak. I was really surprised about weight and stiffness of that machine for the price. I will definitely use that machine for wood cutting, cause it cut plywood really nice, and for some engraving, making PCBs and so on. After some modifications, surely also for cutting aluminium parts. That's about it for today. For more info, price and order, find the link into video description. Thanks for watching, like, share and subscribe if you like, and see you next time.